So this is how our simulation looks so far. And there's a lot of things that I'm liking. For example, we have a certain sense of weight. We also have some small bounce of the particles with the terrain. Also, I like the spread of the particles. I may have it go a little bit higher, but for now let me concentrate on the main thing that I want from the grains. And that is the clustering and the lumping that we saw on the reference videos. So let me go back to the reference. Let's start with this small scale explosion. So right now we have the spreading. We have the small bounce of the particles, but we're still lacking the chunks that we see here while the sand is in the air. Let's take a look at the large scale explosion. Okay, so this kind of chunks and lumping is why I decided to go with grains in the first place. And we're not getting it here. So right now they almost seem as simple particles. So let's tweak the grains a bit so we get a better result. And we're going to do that by setting the grain attraction. So where can we find this property? Select the volume solver, go to the Advanced tab, and look for the grain collisions. So here we will have several options. If you scroll down, you'll find that attraction weight is usually turned off or brought to 0. So let's turn this on, bring this to 1. And let's create another preview. So I will click here on the flipbook and we'll be back in a minute when the simulation is done. Okay, so we're back. The simulation took less than 40 seconds. And now we have a huge difference in the look of the simulation. So notice how we have these chunks that look very nice. They look like sand, and they are much closer to what we have in the references. Also notice this clumping on the floor, which I really like. And still we have some breaking once the grains start to bounce on the floor. So I'm really happy with this so far. There's a few things that I still want to tweak. For example, the chunks are very big for my taste. Also now we have just a small area of the grains being hit or affected. So let's try bringing down the size of the chunks and then making the boulder larger so it pushes more of these grains on the edges. So first of all, let's bring down the attraction, say to 5, so we have less clumping. And also let's go back. If we press 1, remember we have a quick mark set here to the collision. Let's create the radius of this sphere a bit larger, say 0.75. Now here on your node graph, press 2 to go back inside the DOP network, and let's resimulate. So again, I will pause and come back in a second. Okay, now this is looking very cool. So we have this mass and weight that we had on the reference. We also have these chunks and this lumping when the sand falls. We have tinier pieces. Actually, we have some big chunks and some small groupings here and there. And we also have some nice bounce and breaking of the sand once it hits the terrain. So I'm pretty happy with the simulation so far. One last thing that I want to show you is how to add forces to this particle system. So we've done similar things before. If you look for the volume solver node and zoom in here onto the second input, you will notice how it says particle forces. And we can add pop nodes just as we did with regular particles, to affect the behavior of the grains. So let's add a pop drag. Remember, I've mentioned this before. Usually all objects have a certain degree of friction or air resistance. So just with a tiny bit of drag, we will get a more realistic simulation. So let's change the air resistance to 0.05. Connect this to the second input. And also I will add a pop wind. So if you want to simulate the effect on wind on your scene, you may want to add one of these nodes. And then you can add a vector for the wind velocity. For example, if we want the wind to blow to the right, we can add a little bit of velocity in the x direction. Now we will need a merge node just to be able to connect both nodes at the same time. So let's go back to frame 1 and create a final simulation. Okay, so here we have the simulation. As you can see, I overdid it both with the drag and the wind, but it's a nice example for you to see how we can control the particles with these pop forces. So I will tone down both of the forces. So the pop drag I will bring to 0.005. The wind I will bring down to 0.2. And finally, as I mentioned before, I want the explosion to rise a bit higher. So here back on my node view, I will press the 1 key, and on my animation, here on frame 12, I will bring the rock a little bit up, say to 2.1 meters. And let's go with this. So I will create again my simulation. Remember, simulations take a lot of trial and error. So what I would recommend is to create as many iterations as needed until you're happy with the final result. So let me do a final flipbook, and I will be with you in a few minutes. Okay, so now I'm back, and this is the result of the simulation, which I'm really liking. Just a few notes. I noticed here under the wind node, I didn't turn off the air resistance. So by default, this node comes with an air resistance set to 1. And actually, we don't need this air resistance because this is why we're adding the pop drag node. So I brought down this value to 0. And under the pop drag, I increased the air resistance to 0.2. So again, I'm pretty happy with the result. Of course, you could continue to tweak it to your taste, but for now I will save the file and get ready to render. So see you on the next video.